Chapter 11, we're taking a look at the volume of different types of three-dimensional solids. And before we begin, I want to introduce you to a formula sheet that you may use when you're doing your homework or any quizzes or any of your exams. This formula sheet is available to you from your teacher. And on this sheet, you will notice that there are many different formulas, starting with the perimeter of figures. So this would be the distance around. So if we needed to find the distance around anything, we would come to this section to find a formula for the perimeter, basically the distance around. The next one is the surface area. So in three-dimensional figures, if I wanted to find the area of each surface, for example, if I was wrapping a box and I wanted to know how many square inches of wrapping paper would cover all 6 sides of the box, I would look in this section for surface area. So this would be the area of each surface. This is if we have a three-dimensional figure. If we wanted just to find the area of a flat figure on a plane, like a square or a rectangle, we would go to the next section. So here are all my area formulas. And finally, we're going to use the volume formulas for the lesson that we're in right now. So we're going to refer to this page quite a bit to find the volume. You'll notice that there's a couple of formulas listed here for a cylinder, and there's a couple listed for a cone, and the one that is circled is most students' preference. It's a little bit more user-friendly in finding the volume of a cone and a cylinder. So let's take a look. Here's an idea, too, if you'd like to, just very quickly. With your phone, you can take a picture of all these volume formulas, and then you have right there on your phone as you're working on your homework. So number 2, let's take a look at number 2. And we're looking at a figure that is a square pyramid. So let's first of all identify what it is. First name describes what the base is. And you'll notice that the base 6 by 6 in the first one and 8 by 8 in the second one. So they are both squares. And because they both come to a point at the top, they are pyramids. Oops, let's try that again. So I'm going to look at my formula sheet to find the volume of a pyramid. So here's my formula for the volume. 1/3 capital B. Capital B represents the area of the entire base times h, the height. The area of the whole base times the height. All right, so let's take a look. We'll move this guy up here. And we'll find the volume of the first square pyramid. The base is 6 by 6, and the height is 16. And when we talk about the height, we talk about the distance from the point at the top straight down, perpendicular to the center point in the middle, right here. Right there. All right, so the height goes from the point at the top, the vertex, all the way down to the middle point at the bottom of the base. All right, so to do this on the calculator, I can just begin by multiplying 36 times 16 and then dividing that by 3. It's the same thing as taking 1/3. And then when we write the answer to a volume problem, We use cubic centimeters, cubic inches, cubic yards, cubic feet. Volume is cubic units. All right, and then taking a look at our second figure, we're going to use the same formula. The area of the base is 8 times 8, or 64, and the height of this pyramid is 9. So again, I can multiply 64 times 9, and then take that answer, divide it by 3, and we get 192. So it appears that both of the volumes are the same. So in part B, it says both candles are made of wax. Which candle contains more wax? They both contain the same amount of wax. They both have the same volume. Okay, looks like we have the same figure that we were just looking at, another square pyramid. It says right here that the base is a square, and each of the base lengths is 646. And the height is 350. So straight down from here inside, straight down to the middle, some point downside inside the middle, is 350 feet, perpendicular to the base inside. So using the same formula, the area of the base is 646 times 646, or 646 squared, times the height, 350. All right, 646 squared times 350, and then dividing that by 3 gives me a volume. I'm going to have to do a little rounding here. So we have 48,686,866.7 cubic feet. All right, we have another pyramid that also has a square base. And this time we know the side length of the base is 215 meters, but we don't know what the height is. They also give me the volume. So using the formula, volume equals 1/3 the area of the base times the height. I'm going to replace the values that I do know and solve for h, which is the value I'm trying to find out. So in place of V for volume, I have 2,226,450, and that is equal to 1/3 the area of the base. The base is 215 by 215, or 215 squared, and then the height is what we're trying to find, what we're trying to solve for. All right. So let's grab a calculator and let's calculate and simplify the right side of the equation. So 215 squared divided by 3, 1/3 of that, times h. And then to solve for h, we're going to divide both sides. by 15,408.3. So our height is about 144 and a half feet. And that's approximate. Okay, number 6. We need to fill the back of this truck with all of these boxes right here. And the question is, here it is, right here. First of all, what is the volume in cubic feet of each box? And then determine the number of boxes that will completely fill the cargo hold of the truck. All right, so to find the volume of each box, we're going to take a look at our formulas. And this will be considered a, oh, I think it's a cube. Let me just go back. I think it's a cube, but I'm not sure if all the sides are the same. Yes. So all 4 dimensions are 2.5. So we're going to use the volume for a cube, which is listed right here. The volume of a cube is 1 side cubed to the 3rd power. Right? So the volume is 1 side to the 3rd power. So 2.5, and then to cube something, I'm going to use my caret key on the right here to the 3rd power, and that gives me 15.625 cubic feet. All right, and we'll just put this down here so that we can see how we got that answer. All right, now we need to stack the boxes inside and see how many of them will fit. Well, the first thing I'm going to do is I'm going to see how many will fit across the end here, across the width of the back end of the truck. And I notice the back end of the truck is 7.5 feet, all right? So the question is how many of these 2.5s will fit inside of 7.5? How many 2.5s will go into 7.5? And that gives me 3. So I can put 3 boxes. I can stack 3 boxes across the back here. Right? So there's room for 3 boxes. Now I'm going to see how many I can stack high. Well, it's also 7.5 feet high. So I already know that I can put 3 boxes straight up because, again, 2.5 goes into 7.5 3 times. All right, and so I'm stacking them 3 across and 3 high. And now the question is how many of them will fit up the whole back end length of the truck? And that whole back length is 15 feet. So how many 2.5s will divide into 15? And that's 6. So I can put 6 of them. Let's see if I can divide this into 6. All right, so there's 6 going back. 1, 2, 3, 4, 5, 6. So I have on the top row, I have 3 times 6. I have 18 on the top row, and I have 18 on the second floor below that, and then I have 18 on the bottom floor. So the number of boxes is 18 18 times 3. So it looks like I can fit 54 boxes in the back of the truck.